So how to calculate the delay? First, maximum count minus initial count, initial value, initial count. That will become some result equal to result. Some result will come here. Okay. Some result will come here. Say FFF2 was the initial value in the previous program. We came to know that this was the initial value, and what will be the maximum value? As it was a 16-bit timer, FFFF will be the maximum time count. Then what is the result? FFFF minus FFF2. It will be ODH. Sorry, 0DH. 0DH means what? In decimal it is 13. In decimal it is 13. Okay, 13 in decimal. So, however, we add 1 to the 13. So, result plus 1. Because why we are adding plus 1 to extra 1 clock cycle for the result? 13 plus 1, we are making it 13 plus 1. So, 14 we are making. Because why? When the initial value reaches the maximum value FFFF, and again it is going to jump for FFFF to 0000. So one more clock cycle is required to jump from FFFF to 0000. Then only TF0 or TF1 is becoming high. So one extra clock cycle is required, right? So whenever overflow occurring from FFFF to 0000, then that TF0 or TF1 is going to be equal to 1. So it is counting one more no here, plus 1. That is why plus 1 is going to be added to the result. Then, so how much? So this is 0D plus 1, 0E. What is 0E? It is 14. 14 into 1.085 microseconds. That is why, so what is that calculation? 15.19 microsecond. For half the pulse, because I am complementing P1.5 no, in the program. Here in the program, I am complementing P1.5 and I am calling the delay program. When one time, if I call this delay program, it is going to generate 15.19 microseconds. So 15.19 microseconds it is on. It is on. And again, I am going back to the main from this program. This is 15.19 microseconds. Here I am generating microsecond. I am going back to the main program. I am going back to the main program. And again, I am coming to delay program. Again, what I will generate, I will complement the P1.0. So from high, it will go low. It will go low, and again I am generating 15.19 microseconds. So again 15.19 microseconds. So T on time period and T off time period both are same. Okay. So that is why what will happen? Total time period, what will be the total time period here for one clock cycle? It is 30.38 microseconds. Total T. So this is capital T. Total time period. This is T on. This is T off. Okay. So total T is going to be 30.38 microseconds. Have you understood this calculation? This is very much important. Maximum value minus initial value is equal to result plus 1 because of rolling over. Because of rolling over. Have you understood this? See here in this box it is been written maximum number minus initial value. Initial value is YY is stored into TH, XX is stored into TL. Okay, initial value respectively. This is in hexadecimal number plus 1. Do plus 1 into 1.085 microseconds. into 1.085 microseconds. So that will give me a total time period. A total time period. Okay. Then here in decimal, what will happen? Convert YYXX into decimal number. And then what is FFFF? Maximum value. FFFF means 65,536. 65,536 minus n is the decimal number. Here I am not going to add +1 in decimal. Why? Why? Because here I am taking 65,536. Already one has been included here, because what is the maximum value? 65,535 will be there, no? FFFF means 0 to FFFF. It means 65,535. But now here I have already included +1, 65,536. So I will not add +1 here in decimal. Okay. It is equivalent, same. Either I do it in a decimal number or I do it in a hexadecimal number. Have you got to know this? We will end up the session. Have you got to know this? You understood? Yes. Now someone take screenshots of the attendance and participants and send it to my WhatsApp number.